15x to the 5th over 20x to the 3rd. And just pacify me and set it up like I'm going to set it up as 2 times 3 times 3 times x times x times x times x times x over 2 times 2 times 5 times x times x times x. Anytime you're trying to reduce a fraction, you're dividing the top and bottom by a GCF. And to divide, you got to have it as multiplication. So in this case, we can divide by 2 over 2, and we can divide out 3 x's. So on top, we're left 9x squared, and on the bottom, we're left 10. Well, it all comes down to when it's easy multiplication like that. You have 2 of these, I think, in classwork. You cannot, now teachers are getting away from, they don't like the word cancel. I'm going to say reduce, but I am going to put cancel in parentheses. I just can't get away from it. Unless you have multiplication. And I put an exclamation point, and then in big letters, I'm going, you have to factor it. You gotta, I mean, with these, we're easy. We can think about it as multiplication, and we can easily reduce these kind. But it's when you get into others. Now, the other thing I want to address, sometimes I do it at different places, but I want to go ahead and address this too, because when you have rational expressions, you have variables on the denominator, and my question is, when is a fraction undefined? Now, your lesson, I think, is going to say, another way to say it is, what are the excluded values? I'm just going to put that in parentheses. If you were to start plugging in values, what values wouldn't work? Tremendously important with some things that we do a little bit later. Well, go back to slope dude. When is slope undefined? What can you not divide by? What can the denominator not be? 0. So when is a fraction undefined? When the denominator is 0. So if I have 8 over 0, that's undefined. So if I have 12 over x, then when is the fraction undefined? And they're going to call it excluded values. What, when they say excluded values, they say what can x not be? Well, x can't be 0. Now, there's different ways to say it. X can be 1, 12 over 1. X can be 2/3. You can divide 12 by 2/3. It can be any real number except it can't be 0. You can write excluded value is 0. You could write EV equals 0. That means that's the value that x won't be. Now you want to look at how many x's you have. That will help you determine how many excluded values you're going to have. And we'll look at just a couple of examples before we get into it. So if I have a denominator of, what if I have like 10 over x plus 2? And I kind of like starting it like this. What can x not be? I'm just going to ask it, and then we'll talk about it.
It can't be negative.
Can't be negative 2, because x plus 2 can equal 0. Now, to me, that's a better way to explain it. So subtract 2, and you get x equals. So if I have 8 over, now remember, numerators can be 0. That's not an issue. You can make 0 over 30 on a quiz, but you can't make 30 over 0 unless it's bonus points. So you have, let's put 8 over x plus 4 and x minus 3. Okay, in this case, you've got 2 x's, so we've got 2 excluded values. What can x not be? Well, if you say x plus 4 can't equal 0, what will not work for x? If you subtract 4 from both sides, x can't be what? Negative 4. See, x plus 4 can't be 0. Subtract 4 from both sides. Because look what happens. If you put negative 4 right here, you get 0. Everybody look. If you put negative 4 right here, you get 0. If you put negative 4 right here, you get negative 7. So 0 times negative 7 is 0. And 8 divided by 0 is undefined. So it can't be negative 4. And x minus 3 can't be 0, so x can't be 3. So you can do it several different ways. But if there's 2, there can't be, there's 2 values that x can't be. If you were plugging in values, if you were making a t-table, then that is the 2 numbers that won't work. You can put anything else you want to. I can put 8 there. 8 plus 4 is 12. 8 minus 3 is 5. 8 times 5 on the bottom, or 12 times 5 on the bottom, 8 over that, it works. You can't have a denominator of 0. Now, let's step into the classwork. We got, like I said, you got a couple of these. Now, let's look at what's happening. Now, I wrote it on the board, and of course, I guess with the video, I need to put it up here. But I'm going to go over to the side, and let's see. Let me write, the first one is 10 over 2x minus 6. Now, here's the question. If I wrote it up there, if I have 22 over, what did I write? 22 over 32. And I do the factor tree of 22 and 32, I get 11 over 16. Divide by 2 over 2. Make it a factor tree. But if I do 22 over 32 and do this, I get 2 over 3. Now, why is that crazy? That's because you're trying to cancel the adding. See, 22 is 20 plus 2, and 32 is 30 plus 2, and you can't cancel addition. You can't cancel subtraction. You can only cancel multiplication. That's where you get you right here. 10's fine. 10's 2 times 5, but that's not multiplication. How do you make it multiplication? You have to factor it. First factor you need to look for, you have quite a few of them in your classwork, is GCF. If I see it and it's just a binomial, we take out the GCF, and what is that? 2, and we have x minus 3. Now, I factored it into 2 terms. 2 terms. So, and I'm especially interested in what x can't be. 2's not ever going to equal to 0, so I don't worry about 2. It's going to stay. It's a constant. But x minus 3 cannot be 0. So x cannot be positive 3. That's my excluded value when it asks for that in the classwork. Now let's reduce it. And you want to get your excluded values before you reduce it. It doesn't affect it here, but it can affect it. Because if some of your x's go away, it looks like that they would work, but they still won't work if you were doing a factor tree. So pay attention to the degree or the exponent of your x, and that will tell you how many excluded values you're going to have. So this is multiplication. The 10 and the 2 will reduce, and I get 5 over x minus 3. Now, depending on how you did it in Algebra 1, I made them leave the parentheses on it, at least from the beginning, because x minus 3 is a factor, and it will only cancel if you take a whole x minus 3. This is where your quiz 13 comes into play. Let's do n squared plus 3n minus 18 over n squared minus 11n plus 24. Now, it's addition and subtracting. Do not cancel until you make it multiplication, just like we made 18x to the 5th at multiplication. We can make this multiplication because we know how to factor it, and we can make this one multiplication because we know how to factor it. We know there's 2 excluded values, and that will come up right here when you get it factored, see, squared. So the top is n and n. We love coefficients of 1. This is a negative. I know I'm going to have to think subtraction. And so it's going to be 1 and 18. And I'm trying to wean you away from that too. 2 and 9 or 3 and 6. Now, which combination will give me a 3 in the middle?
6 minus 3.
The 6 and 3. And you're saying this one has to be positive and this one negative? Okay. Now, we love this one because it's n and n. To multiply to be positive and add to be negative, they both have to be negative. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Which combination will give you the 8 and 3? And I'm going to actually put the 3 here and the 8 here for a reason, because I think a lot of people, see, that's a big fraction bar. You've got 2 factors on the top, just like you had a bunch of factors up here. We've got 2 factors. Let's stop and do our excluded values at this point. What can x not be? Oh, what can n not be? Thank you. N can't be. Okay, what would make this one 0? 3. And what will make that one 0? And that we factored it. The factors have to be identical. Like you can't cancel a 2 and a 3. So you can only cancel an n plus 6 if you see an n plus 6 on the bottom. It's the whole factor. So I see an n minus 3 and they're gone. And I'm left n plus 6 on top and n minus 8 right here. Put parentheses around it at this point, because then I see people go off the deep end here and they start marking out the n's and they start marking out the 6's and 8's. You can't cancel adding and subtracting. You can only cancel the fact. See, that's a factor, that's a factor. This times that. It has to be one of the factors, and I will tell you, every problem you have from me, something will cancel. I don't give you any that are already reduced. You know, like in math, the teacher might give you 11 over 20 and it's already reduced. Well, I'm going to get every problem you have from me is going to already be reduced.